So we're going to start off today by reviewing a little bit of scientific notation. Then we will go into acids and bases. We will talk about pH, and then yeah, that'll be it for today. Okay, so this isn't unique just to scientific notation, but it is important to know that anything with a 0 exponent is equal to 1. Where is my, here we go. Okay, so no matter what the number is, if the exponent is 0, it's going to be equal to 1. So scientific notation is going to be helpful when we are studying pH, mainly next time, but it will come up a little bit today. So one of the times where you may have seen scientific notation is before, when we talked about Avogadro's number, which is 6 times 10 to the 23rd power. So right here, the times 10 to the 23rd is scientific notation, and it really exists as a shorthand so that we don't have to write out our whole number, because this would be 6 with 23 zeros at the end of it, which is too much to write out. That's crazy to write, okay? So that's the purpose of scientific notation. That's when we've seen it before. One of the most important things to know is just the distinction between negative exponents and positive exponents. So 10 to the power of a negative exponent, that is basically telling you how many times you're going to move your decimal to the left. So if we had, let's say, for example, 3 times 10 to the negative 4, this part, times 10 to the negative 4, is telling us we'll move the decimal on our 3, 1, 2, 3, 4 times to the left, okay? So the bigger our negative exponent is, the more times we're moving our decimal to the left, the smaller the number gets, okay? So it's important to know the more negative your exponent is, the smaller your number will be, because we're moving the decimal to the left even more times. So the more negative the exponent, the smaller the number you have. And of course, with positive exponents, the opposite is true. Positive, if we have a bigger positive exponent, then we will have a bigger number. Because we are just tacking on more zeros at the end, our number would be getting bigger and bigger. So with scientific notation, you will not have to write it on your own. You will just have to be able to recognize, oh, this is a negative exponent, it must be a really small number. Or this is a positive exponent, it must be a bigger number. That's all you will be asked for. Do we have any questions about this? My cat's going crazy. Questions? Okay, well, we're going to move on then to talking about acids and bases with some facts about them, and then we will go over what do these facts even mean. All right, so acids and bases. What are some facts? So we will learn, this is maybe a little bit out of order, we'll learn about something called pH. pH is a scale of numbers ranging from 1 to 14. What you have to know about acids is that they are on the lower end of the scale. So if anything has a pH value that is between 1 and 6, that's considered a low pH value, which means it is an acid. All right, so if, for example, something had a pH of 3, we would instantly know, oh, this has to be an acid because it is on the lower end of the pH scale. Conversely, bases have a higher pH. If anything is between 8 and 14 on the pH scale, then we know that it is a base. It's a high pH. All right, so if we have an acid, what does it actually look like? One way to recognize an acid is that it will be a solution that is full of H plus ions, okay? A solution full of H plus ions. H plus is another way that we can just say that is proton. Why am I trying to spell this out? Proton. Okay. The reason for that is because a hydrogen ion is one proton, one electron. Right? H plus means it's positively charged. It lost its electron. So what's left is just one proton. So H plus and proton is literally the same thing, okay? So we can say the solution is full of protons. On the other hand, a base will be a solution full of OH minus. And OH minus, that ion is called hydroxide. If I say hydroxide, that's what I'm talking about, all right? So just to recap, something is an acid if its pH value is somewhere between 1 and 6, although some scales do go down to 0, okay? And then it has a lot of protons in its solution. And something is a base, hold on my cat, Harriet. Something is a base if it has a higher pH and if it has a high concentration of hydroxide ions in solution, which is OH minus, okay? So those are general descriptions of acids and bases, but we can think, okay, we did our little unit on reactions way back in like November. We know that molecules and compounds, they do things, they react. So what do acids and bases actually do, okay? Because if they just sat there and did nothing, we wouldn't be talking about them. So what do they actually do? Let me clear this. An acid, when it is in a solution, it does what we call protonating. It protonates, which means that it basically gives off its protons to other substances. And again, proton is H plus, okay? It is giving off its protons. It is protonating. If I were an acid in a solution, I would just say, okay, take a proton, take a proton, take a proton, right? Acids give off their proton. And then bases, we're gonna learn acids and bases are kind of opposites, but they're very complementary. So bases, what they do is they accept protons, okay? So acids donate them and bases accept them. Do we have questions about this?
No, we don't.
Okay, so what I'm gonna do now is draw a figure that hopefully, in my mind, it's helpful because it puts all these facts together kind of into one coherent thing where I can think of it and say, ah, everything makes sense, I get it, all right? You can write it down. You can just watch. It's up to you. It's really just explaining everything that we just said. Okay. So let's talk again, a quick recap of acids and bases. So far, we've learned that acids, what they do is they protonate, meaning they give off a proton. And what else do we know about acids? That in solution, they are a solution full of our protons, H plus ions. Okay. And then what do we know about bases? We know that they accept protons. They accept protons, and their solution is full of our hydroxide, OH minus. Okay, so how can we kind of merge these facts in our head and make them make sense? So we will go through an example of acids, and it's important to know when we say solution, like, oh, an acid in a solution, what we're talking about is most of the time, if you imagine like, ooh, a dangerous acid in your head, maybe something you've seen on TV, it's usually a liquid, okay? So most things, when they are liquids, it really means it's a solution where it's dissolved in water, okay? So for example, one of the strongest acids, HCl, AKA hydrochloric acid, okay? I'm gonna mark this as acid so we remember. Hydrochloric acid. If we have it in liquid form, that means that it has been in a solution with water. We could have another solvent, but for our purposes, most of the time we're going to say water, okay? So hydrochloric acid is our solute. Water is our solvent, going back to last unit. Okay. And then what is an acid going to do? It is going to protonate, meaning this proton that it has right here, again, proton are hydrogen. It is going to give it off. The only other substance that's there is water, so it's going to give its proton off to water. That's what it's going to do. As soon as we put them together in solution, that's what's going to happen. So what are we going to be left with? We have just Cl minus, a chloride ion, because it lost the H, plus water, but remember a hydrogen was added. So what this will look like is instead of H2O, it's going to be H3O. But really, what H3O, what that really is just H2O with a proton. Okay, H2O with a proton. So we can see, hopefully this will start connecting things together. What did our acid do? Our HCl gave off its proton. And in the end, what are we left with? We are left with water plus a proton floating around. Okay? So that is why when acids give off their protons, we saw that, we end up with a solution full of protons. Okay? Because we will have that H plus. Similarly, we can do an example of a base. The base we'll use is NH3. NH3 is ammonia. NH3. And again, this is in solution with water. All right, and what do bases want to, let me write base. What do bases want to do? They want to accept protons. Accept protons is a nice way of saying they kind of want to steal a proton. They're only with water, so that's the only thing it can steal a proton from. So it's going to go ahead and steal a proton from water. Once it has stolen its proton, what are we going to be left with? Well, NH3. We took a hydrogen, okay? We took that proton. So now we're going to have NH4. NH4, because we took that. And what is going to be left with the NH4, right? If we had water, water is H2O. We can draw it like this. Okay, water is H2O. It looks like this. One of these protons, whoop, got stolen. So what we are left with the water that has lost its proton is just OH minus. Okay, that is what is left over when we took this proton off of water. So that is why bases make solutions that are full of OH minus. That is because that is what is left once it has stolen the proton from water. Okay? So the base took a proton from water. All that's left is OH minus. That is why we can also define bases as solutions that are full of OH minus. Does that kind of make things, make these facts kind of merge in your head? Maybe, maybe not.
Yes.
Okay. Thank you.
Yes.
Okay. Thank you. So one interesting thing, we skipped this in the beginning just because some classes were too chatty and some classes didn't say anything. But a lot of people, when you hear the term acid, you usually think of like cartoons where people fall in a vat of acid and all their skin burns off, or all sorts of crazy dangerous things with, oh, someone got acid on their skin and now they have a hole in their hand. So all of those things you think of with acids, the word for all of that is really corrosive, meaning it can damage a surface or something. So that is true of acids, but it is also true of bases, okay? So if you have a strong base, it can also burn through your hand. It can do all sorts of damage. So we can think, if we have a really strong acid, which can be dangerous, powerful, can burn through something, and we put it with a really strong base, which is also super powerful, can burn through stuff, can melt away your skin. If we combine them, what are we going to get? Are we going to get ultra, super, mega strong? Is it going to be double as strong? Is it going to be just as strong as before? What's going to happen? Nobody wants to take a guess? Alrighty, well, what happens when we combine acids and bases? We know that acids are solutions full of H+. We know that bases are solutions full of OH minus. When we do H plus OH, what do we get? The most dangerous thing ever? Somebody just tell me what that is.
Water.
Water. Thank you. Okay. This is one of the coolest things ever. You can take an acid, which has potential to be very dangerous, a base, which has potential to be very dangerous. When you combine an acid and a base, what do you get? You get water. Okay. Because we have all of those H's, all of those OH's, they make H2O, water. Okay. We're going to be talking about that more in 2 classes from now, but we describe this as saying they neutralize each other. They neutralize each other. We have an acid, we have a base, and we get water. I don't know if y'all think that's cool, but I think it's super cool. Any questions about this?
No.
Okay, so then moving on, we're going to talk about the pH scale a bit, which we've already talked about. Okay, pH scale is used to measure how strong is an acid or a base. Okay, and the pH scale is not random numbers that are just made up arbitrarily. It is actually a calculation using the concentration of protons. Okay, the concentration of our hydrogen ions. That is what this whole scale is based off of. So again, we talked before, anything below 7 is in the middle. Anything below 7 is an acid. Anything above 7 is a base. Okay, pH, oh, I forgot to say this. Fun fact, pH actually stands for, it's always a lowercase p and a capital H. It stands for the power of hydrogen. Fun fact, that's what it stands for, okay? So that's what the scale is based off of. So anything, again, below 7 is an acid or the adjective form. Anyone know what's the adjective form of acid? Acidic, okay? And then above 7 is a base. What's the adjective form of a base? I know y'all know this word. Maybe you don't use it in this context, but I know y'all know this word.
We don't know it, miss.
Basic. Something's a base, it's basic. Okay. All right. And then the important thing to know is the center. Okay. The center is neither an acid nor a base. The word we describe it as is neutral. Okay. So if something is 7, it is neutral. And the closer something is to 7, the closer it is to neutral, meaning we can say the weaker it is. So closer to 7 means that it is a weaker acid or base. For example, 6, pH of 6, that's technically an acid, but it's really close to 7. So it's going to be a weak acid. So an example of that would be milk. Okay, milk is a really weak acid. When you think of milk, you probably don't even think of it as being an acid because it is, sorry, my mother is bothering me. You don't even think of it really as being an acid. It's a weak acid. Versus if we go all the way away from 7 to the end of the scale, we have 1. That would be something like gastric acid. That is a really strong acid, okay? So 1 would be the strongest acid because it is the furthest away from 7. Similarly, 8 is a base, but it's really close to 7, so it's pretty weak. That would be something like an egg, okay? It's a pretty weak base. Versus 14 would be the strongest base. And it's important to note, when I'm talking about weak and strong, I'm not just talking about, oh, can it hurt you? Which, I mean, is relevant, but really when we're talking about strong, we're talking about, can it take protons really well? Can it give protons really well? That. So like the action of acids and bases, how well it does that. So for example, a base accepts protons. So a weak base would be bad at accepting protons. Okay, that's what I mean by weak and strong. But you can also think of it in terms of a weak base isn't going to hurt you, but if you pour a really strong base on your skin, it's going to pull those protons out of your tissue, and you're going to end up with some damaged tissue, some tissue damage. Okay. Any questions about this? Oh, I forgot to mention again, the only thing that is really like pure, truly neutral would be pure water. Okay. That is because it is equal part base and equal part acid. So an H and an OH, what does that make? It makes water. Like we said before, that's literally the definition of neutral. You got a base and an acid, and it makes water, neutral. Do we have questions? All right, well, we've got one last thing. Can I clear this slide?
Yes, you can.
Okay, so we've got one last thing to go over, which is what is the relationship between, we said here that the pH scale is based on the concentration of hydrogen ions. What actually is that relationship? The relationship, if you look at this orange square here, it is inverse, okay? They have an inverse relationship. We will talk about why. So a higher proton concentration. A higher proton concentration means it's going to be a stronger acid, right? Because we talked about acids. What do? They put protons in the solution. So the more protons, the stronger the acid. So more protons means more acidic. But we talked about on the pH scale, the strongest acid has the lowest pH, right? We're talking pHs below 7, the lowest pH. So this is an inverse relationship. The higher the hydrogen concentration, the lower the pH. You could also say it's an inverse relationship between acidity and pH. Because the more acidic something is, the lower the pH is. The opposite, if you have a really, really low hydrogen concentration, then we're talking about a base. The more basic something is, the higher the pH. So this would be a low hydrogen concentration and a higher pH. Again, that is an inverse relationship. All right, and then we're gonna look at this little graph down here. The graph it has a lot going on, so I'm just gonna focus on what we care about right now, which is what this square here, hold on, I'm getting rid of this momentarily. What this square here is showing us is at different pH levels, whether something is an acid or a base, it's always going to be a ratio of how much hydrogen ion do we have and how much hydroxide ion do we have. It's always going to be a ratio. So over here would be pH 0, the strongest acid. Over here, pH 14, the strongest base. And you can see here where it's the strongest base, it is all hydroxide. Okay? The strongest base we've got, it's all hydroxide. Similarly, the strongest acid is all proton. Okay? That is because it is all acid, no base. It's just pure protons in the solution. Right smack in the middle, though, at pH 7, where it is neutral, you can see we have an equal amount of the proton and the hydroxide. Equal amounts. And every pH in between is just a different ratio of our protons to our hydroxide. Okay? That's what this image is showing you. And we will also look at this image a lot next time. So don't panic if you don't feel super familiar with it yet. Do we have questions about this? No? Okay. Well, what we're going to talk about now is some really cool applications of pH. I love talking about pH because it really impacts everything in the world around us, everywhere. So next class, what we will be doing is we will be reading, not ahead of time, but actually in class, y'all will be looking at different articles about how pH impacts us humans, and also the environment. And y'all will be kind of summarizing it for your classmates. So next class, you need to have access to those articles, whether that is you have them in a separate tab on your computer or you have them pulled up on your phone, etc. Where are they? They are in what I always link to, online school. If you go to the online school folder, then there is a folder called pH articles, okay? And we will be reading these next time. Just make sure that you can quickly click to them when you need them, all right? But we will look today at a sneak preview of one way that pH impacts our bodies. So human bodies are very finely tuned machines, okay? And one thing that your body is excellent at doing is regulating pH, because all the different parts of your body have very specific pH levels that they need to function properly. Your stomach has to be at a certain pH, your skin has to be at a certain pH, your eyes have to be at a certain pH, your saliva has to be at a certain pH. Everything needs to be exactly at the right pH, okay? One thing that can make people very, very sick is your blood pH has to be very tightly regulated. And one thing that can mess that up is if you are not getting enough oxygen. Let's say if you're at a high altitude, there's not enough oxygen. Instead of just, oh, you feel sick because you don't have enough oxygen, lack of oxygen actually makes your blood more acidic. So that causes a whole slew of problems, aside from just, oh, you need more oxygen. It can really, really mess you up. So what we're going to watch now is about stomach pH, and how this can lead to some issues.
Sometimes your health comes down to the simple numbers, and I'm here with gastroenterologist Dr. Rodriguez. We're going to discuss how your pH number could be responsible for pain, and of course, pH refers to the acidity in your body, right?
Absolutely. It's
So-
a measure of acid.
So pH of your esophagus, how does that affect my
Well,
health?
let's start off by saying that your stomach is what makes acid. So acid needs to stay in the stomach or go down the intestine. If it comes up to the esophagus, it's not a good thing.
So gastroesophageal reflux disease is when that acid or those acid contents of your stomach go up into your esophagus. We have an animation
Exactly,
here.
which is beautiful. Think of your stomach as a volcano, and the lava, which is the acid, has to stay in the stomach. When it comes up, like a volcano burst, that's bad. That's reflux.
So normally, this right here, you should have a lower esophageal sphincter that will stop the contents from going back up into the esophagus. But sometimes
Sometimes you don't. Sometimes some people are born with hiatal hernias where that sphincter is too open. And sometimes we eat so much that the actual contents of the stomach open up the sphincter. That's why we get heartburn.
Okay. So what they were talking about is the acid in the stomach, which we know, of course, is acid is a low pH. What happens when that gets into your esophagus, which is, they are referring to acid reflux. Also, you can talk about it being heartburn. Has anyone ever experienced heartburn or acid reflux or know what the symptoms of that are? What are the symptoms of acid reflux or heartburn? Anybody know? Well, I can tell you with heartburn, it's literally in the name. What's the symptom?
Your heart hurts or burns?
Yeah, with heartburn and acid reflux, you have a bad burning in your chest. Okay, your chest feels like it is burning. And the reason why is because all of the acid in your stomach has special lining, okay, to protect the tissue from the acid. Your esophagus, however, does not. So if that acid, a little bit of it creeps up into your esophagus, it feels like it's burning because you've got acid in your esophagus. It's a very painful and uncomfortable feeling, okay? This feeling of having acid in your esophagus, you may have also experienced this if you have ever thrown up and then felt like your whole throat is on fire, okay? That is also because you have that acid in your throat, not your throat, your esophagus, okay? And that is what causes that painful sensation. It is because the pH has become too low because of the acid, which is I think, an interesting thing.